From this video now on, we are starting the series of function programming in which we will learn the core concepts of function programming like function composition, function decoration, layers, and pure functions, immutability of the functions, and also we're going to learn partial applications and coding. Well, let's talk about functional programming in general. Functional programming is a pattern or a paradigm or a way of writing the code or organizing the code. So what are like functions and why we need functions? So let's say I have a big program. So let's say I'm building a calculator. Okay, so I'm doing like addition, multiplication, subtraction, division, modulus operator, and things like that. We might need all of these like stuff, but at the same time it would be just in our website. Okay, our website may contain other things as well, such as like would have calendar, it would have weather, it would be like having directions to our office location, and in calculator as well we need to like just like split them, because we won't always like adding the stuff. We won't be adding, we won't be always subtracting the things, we won't be always dividing the stuff. So dividing the code and making it to tiny pieces and reusing those tiny pieces or small pieces when we need them, and those tiny pieces or reusable code are called functions. Okay, so we divide our big program into a little bit of functions, so we only use the functions when we need them, right? So let's start with our first function. That's how you do declare a function, and there's a keyword called function to make a function. Whatever you want to like name that function, you can name it over here. So let's say I'm doing a function called function multiply by 2. I'm making a function for multiply by 2, and this is gonna be, and these parentheses are for like accepting the parameter. So let's say I want on the number which is passed from the user, so it would take that. So this is called like parameter. If I hover it, it would give you the parameter as well. Okay, so whatever is like passed to it, we can do stuff with that, and we will see in a minute that what it does. Okay, whatever the definition of the function is goes inside of the curly brackets. Okay, so what we will do is, and so whatever like user passes a number. Okay, so whatever the user passes a number, we're gonna like declare that number over here, and we're gonna say var num is equal to 5, and I'm gonna like 2 is a return num, this would num, okay, by multiplying it with the 2 multiply. So we're basically doing is taking that number that we will pass. We didn't pass it yet. Okay, we will pass it in a minute. So what we're doing is passing this number as an argument. So what we pass is called argument, and what this actually is like parameter, and we multiply it or do whatever like calculation we want. So in our case, because we are doing making a program or like function for a like multiply, and we are multiplying it by 2 and returning that. So it will like take num 5 and multiply it with the 2, and it would give us like 10 and return that, and we would have to take that output in some variable as well. Okay, main point is to like explain how the JavaScript executes the like code, and then I'm gonna go into the functions. Okay, so let's say I have another thing which is called like here I'm declaring a string, my string, and my string is like my name is Zaid. Okay, this is a string, And now I will go to Firefox and explain you with the Firefox developer tools. So let's go into the Firefox developer tools. Here my Firefox is, and I have opened it with my live server. You can install the live server application. Okay, so this is called live server. You can go to over here, search for live server and install it, and you can then just press F1 and search for like live server, and click on this live server, open with live server. So you won't have to like refresh the page every time you make changes to your program, so they will automatically be reflected into your browser whenever you like refresh the whenever you like make changes over here. So you won't have to refresh that, and then you can press in Ctrl+Shift+I to open these developer tools, or you can go over here. We're gonna do a lot of stuff over here, visualizing the things, and we will the first we will open the debugger. Okay, and if I like refresh this, we got this our script file. Okay, and here we go. Let me remove this by default. Okay, so I'm gonna add some breakpoints to our stuff. So here is the thing, in JavaScript how our program executes is line by line only. Okay, so when our first line gets executed completely, then it moves to the second line, otherwise it doesn't move to the second line. So this is like thread of execution, like thread, like line by line thread of execution is like line by line, like synchronized. Okay, so when it is executed, it would go to the second line, and when the second line is executed, it will go to the third line, and then so on. Okay, so I added 3 breakpoints, one to the like first line, and then I add to the third line and the fifth line. I'm gonna like watch these as well. Okay, so I'm gonna add this to my watch expression, so this would go over here. So I'm gonna do is add watch expression over here. Okay, so this is watch expressions. So, and I'm gonna add this my string to watch expressions as well. I'm gonna refresh the page. So here's the thing, everything is like stored in a memory. By default everything is stored in a memory, and that memory is called the global memory. You can see a stack over here, so this is a global, is showing that global. Everything that we write in a script file will be stored in this global memory. Okay, by default. And so we added this. By default the num is undefined. Okay, at this point, because I added a breakpoint, it stopped it. This line is not executed completely, num is undefined. So I would go type in F11 or click on this, and when okay, so this line got executed and the num changed to 5. Okay, I want to like refresh this again. Concept I wanted to explain is, what do you think after executing the first line, would it go to this function line, would it go to the second line, which is multiply by 2? The answer is no, because function definition is just stored in the like global call stack, and it does not go to its body or anything which is inside of it, or like taking that parameters uh, until and unless we call this function or invoke this function multiply by 2. So it would like directly jump from first line to the fifth line without executing this function or checking for this function. It's just stored in this in the global stack. Okay, now I'm gonna do is step in, the num is 5. You can see the thread of execution jump directly to the fifth line, and when I go and type it, click on this again, it would do is would assign the my string to my name is Zaid. It was like my undefined and then when I click on this again, our program executed completely. It didn't even go to this multiply by 2. So now I'm gonna do is call my function. So I wanted to like explain this concept, because the function does not get executed until unless we're called this. Okay, I'm gonna call this multiply by 2. I'm gonna pass in the num, which is the 5, and now it's gonna be executed. We can go over here as well. So let's execute this again. We got it. Num is undefined. Line executed. Num is 5. Now line 5 would execute. My string would turn it to my name is Zaid. Okay, now it got to line 6, which is multiplied by 2. It would call this function and pass the num as an argument to this function. Okay, so and I call this, you see a call stack happen. In call stack there is a global memory, and one is like global memory, and one is like multiply by 2 is our function. Whenever a function is called or gets invoked, the thing happens is that function is added to the call stack, and when it gets executed completely, and this call stack it's like added to the call stack, which is a like local memory, like local a new execution context for this function. And when this function executes completely, this execution context is gone and it would be like removed from the call stack. And you can see that at this point the num is 5. Okay, the num is 5 because we passed it num 5. Now this line 3 would execute and it would change the num to 10. I would go to again, so it is again num 5 for some reason. Okay, it didn't get out of that. The line 3 executes, and when but it didn't get out of the curly brackets. When it gets out of the curly brackets, it would turn into 10. Okay, so our num is now 10, but we can't see it because I didn't print that. I'm gonna like print, I would have to take that into a some variable, the return of that function into sum. So I'm gonna take that into a result. I'm gonna console log result as well, and I'm gonna like refresh it again. Gonna go faster this time. Num is 5. It's gonna like change it to 10. So you can see when I overrode it, so it got executed. The result initially got no value. Okay, so this result gets the value which is the return value of the like multiply by 2. Okay, whenever you see on the right side a function or whatever, it would not be the like value, it won't be the like like completely giving the function to the result. It means like execute the function, and whatever the return value is, give that to the result. Okay, so now the result is 10, and we are logging the result. I'm gonna step in again. Okay, so we got a step over. I'm not watching the result, is for that reason it's not showing in the watch expression, but the result is now changed to 10, and it's console logging, and it executed completely, and we because logged it, and we can see over here the result is 10. Whatever we console log, we can check it over here, or if we want to do something by ourselves, we can do that. Num is equal to change that to 11, and we can do that as well, and now the num would be changed to 11. And I'm gonna like go a little bit more into the like call stack. I'm gonna define on 3 functions. Okay, first function. Okay, so this is a function. I'm gonna just copy paste this. Okay, wait, hold on. I'm gonna like take a variable which would count the functions, which is total functions is equal to 0. By default the function count is to 0, and whenever a function executes, its value is increased by 1. Okay, so I'm gonna increase the value total functions plus plus. That means whenever like a function is executed, or whenever I call this function, increases value to 1. Okay, and I'm gonna define another function which is gonna be second function. inside of that I'm gonna do the same thing, and I'm gonna call the second function inside of the second function, inside of the first function. Okay, so when our first function executes, it's automatically gonna call the second function. Okay, so okay, but hold on, I'm gonna like copy paste it for third function as well, and I'm gonna like in second function I'm gonna call the third function. So it's like a chain. When a first function is called, it's automatically gonna call the second function, and I'm gonna like remove this because after this I'm not gonna call any other function. Third function, when I call the first function, the total functions would increase to 1, and it would call the second function. It would be added to the call stack. The now it would be increased to like 2, and the third function would be added to the call stack. It would be increased, and then it is gonna call the function third function, and then it would go over here. It would like change to 3, and when it gets executed, the third function would be like pop off of the stack, then the second function would pop off the stack, and then the first function would be pop off the stack. The reason why is why the first function won't be pop out of the, because I'm calling the second function inside of the first function. Until unless the execution of second function is not completed, the first function execution is not complete, and I'm calling the third function inside of the second function. And until unless the third function is not executed completely, the second function is not gonna be executed completely. So third function would pop out of the stack first, then second function would pop out of the stack second, and then it would pop out of stack. Let's see it in browser in action. I'm gonna remove my string, and I'm gonna like now I'm gonna add total functions to my watch expression. Add watch expression, and I'm gonna add breakpoints to, oh okay, I didn't call the first function anywhere, and I would have to like call the first function as well. First function, so I'm gonna add a breakpoints over here. Breakpoint. So yeah, let's refresh it again so we can see its execution. Let's do this. So we got at the line 9 first. The total functions by default is undefined. When it get executed, it would get the 0 value assigned to it. We will step inside of that. Now total functions is 0. Now we are in call stack. That means we are in global. There is a jumped off like directly to line 24 because these are just in memory, and when they get pushed inside of the stack whenever they are called. Okay, so when I call this first function, and we jump directly to line 24, and when I just call this first function, okay, then we would go to line 12. This first function would be called, and we will go inside of the first function. We got inside of that. Total functions is now 0. By the way, you can see the call stack, the first function is added. Okay, you can see this first function is added, the call stack, and total functions is now about to execute, and when I step in, it will change its value to 1. You see the value executed to change to 1, and then the second function is called. And when I call the second function, the execution of first function is not completed. It's directly gonna jump to the second function, and it's executed, and when it is executed, it's gonna complete its execution, if that makes sense. Okay, so I'm gonna like step in. I'm gonna go about to call the second function. When I call the second function, the second function is added to the call stack. Okay, so that means a new local memory and a new execution context, and when this function executes completely, this execution context is gone and removed, and it would be pop out of the stack. And inside of that, I'm increasing the total functions count to one more time 2, and then I'm calling the third function. So the second function won't also be a pop out of the stack, because I'm inside of the second function, and inside of second function I'm calling another function which is third function, and then third function would be added to the call stack as well. So I'm gonna go inside that, I call the third function. The third function is also added to the function. So we are about to, at this point, total function is 2. We're about to execute the line 21. We are gonna be executing, and total function change to 3. And now we are at the, you can see we didn't even touch the last bracket of all the function. We executed this and directly jumped off to that function execution. Okay, so now at this point, because we are not calling any other function, so we are hitting the curly bracket, the closing curly bracket, so that means it would pop it out of the call stack. And step in F11, the third function is executed. The second function, the closing curly brackets, was not executed because we executed third function directly. So I'm gonna like step in, and it's about to remove it out of the call stack. And yeah, for some reason it didn't get executed. Okay, yeah, now it got out of the call stack. Now we're about to move out of the call stack of the first function. Now we are in global. Our program executed completely, and if I like click on it again, we go to index file, or all the functions got executed completely. The total function is now 3, and yeah, that's it. Hopefully you got a little bit of understanding of functions and call stack. We make the functions because we do not want to like slow down our app. If we make functions to like just store them in a memory, and make execution context of that, local execution context of that when we need them, so like they are like reusable pieces of code for us. That's it for this video. See you in the next video.